In this prototype, we want to allow players to fire volleys not based on the other players, but fire one volley based off of how many active pieces they have. So if you have 3 ships, you should be able to fire 3 volleys for those ships, or the ships may be even be able to specify how many volleys they're able to fire. Because otherwise, it's not that you're raining fire from above, the ships are presumably shooting at each other. So in order to do that, let's start with our multiplayer code. And let's think about what we might do to extend this. Well, to extend this, the piece itself might have the number of volleys that it can fire. So let's say the battleship can fire 3 volleys and the destroyer can send 1 volley. Because we kept track of the active ships, what we can do is we can say for this player, and I'll do this. I'll continue, and I'll just print out the player so you can see the player. I can figure out, and let's continue here and then breakpoint right after. So for the active player, I can actually figure out how many volleys they're able to fire because I can ask for their board and I can ask their board for how many active ships it has, and it gives me all the ships that were active. And because I didn't throw away that information, I didn't have this return a true or false value, but instead I had returned the actual pieces, the entities themselves, and then made the determination based off of that. For example, you could code a version of this game that runs until you sink the carrier, and once you sink the carrier, everybody else runs and flees. Then you could do that because you didn't hard code the presumption of what constitutes the end case of the game in this active ships by just returning a true false value. But what I could do is I could just do this, sum ship.volleys for ship in this. So that's how many volleys you have. So it turns out, even though, did I not call it volleys? Oh, and I probably want to pass these through in this enum. So there we go. So there we go. So now you can actually see that presumably the ones who are hit the most are going to degrade their ability to play this game over time. They're going to need a better strategy, or they're going to need a little bit of luck if they want to stay in the game. So what I'll do here is I'll say, okay, this is for each opponent. What you might choose to do is you might choose to, I guess your volleys should determine how many different opponents you can hit. So what we'll do is we'll cycle through your opponents, and then we'll slice this to the number of volleys you have. So then you'll basically fire in round robin style until you run out of shots or volleys, as it were. So here we go. And so I think we just need iSlice and cycle. So you can see the game plays a little bit differently, and you can see Charlie seems to be doing pretty well. I guess Charlie was never hit, and so Charlie had an opportunity to fire at a lot of people and to determine, the state of the game based off of, if you're never hit, then you have more capability to hit other people, and then you just keep doing better and better and better. But with that said, one of the things that we can see is some of the approach that we've taken is actually quite durable, and some of the choices that we made are actually quite durable to significant changes in the requirement. We have a very sophisticated version of the game here, even though we haven't implemented 1 or 2 core pieces like being able to really latch on once you figure out what the orientation of a piece is, or actually the random positioning of the board.